Ladies and gentlemen, so today we have one interesting question which we attached to a previous question we previously discussed. I will attach the link in the description of this video below. So we know for sure that the question here reads to say, suppose there has been only 10 past CEOs of a company. The following data is the number of years each has served as CEO in the company. So the names of the CEOs which have served in this particular company are here. We have Roger, Mark, Amos, Mainga, together with Paul. And these are the number of years they served respectively. So remember in the previous video, we discussed in how to calculate the population mean and the population standard deviation. So these are the values which I have just written there, but I will attach the link so that you watch the video as well. So the question that we have attached here is B, which is reading to say, if repeated samples of 2 were taken from the population without replacement, what is the sampling distribution data? So what we basically do here is this. We will just get the number of years these people had served. We have 5, 6, 8, 9, and 11. So these basically are the number of years these people served. So since these are the number of years these people served, remember we want the sampling distribution data. So we will write sampling distribution data here. Remember we are just grouping them in twos, as they have said, if repeated samples of 2. So what we do now is, remember this is of Roger. So Roger will bunch him together with Mark. The same Roger will bunch him together with Amos. The same Roger will bunch him together with Mainga. And the same Roger will bunch them together with Paul. Then we have, we are done with us using Roger's figure. We will now go to Mark. But remember, when you go to Mark, you are not allowed to write 6, 5, 6, 6. Why? Because they have said the population without replacement. So we are not allowed to repeat, nor are we allowed to replace. So we just continue 6, 8, 6, 9, and 6, 11. We are done. We go to Amos. So for Amos, we have 8, 9, 8, 11. Let us put commas in between. So we are done with that of Amos. We can go to Mainga. So Mainga, you have Mainga to be 9, 11. So let us count the sampling distributions that we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now that we have this sampling distribution data, remember we want to calculate what is referred to as the mean. So how do you calculate the mean in this kind of instance? So you will be adding 5 plus 6, you get your answer to be 11, divided by 2, you get your answer to be 5.5. Again, you add 8 plus 5, divided by 2, you get your answer to be 6.5. You also do the same, 5 plus 9, you divide by 2, you get 7. Here we have 5 plus 11, we get our answer to be 8. And we have 6 plus 8, we get the answer to be 7. And we have 9 plus 6, we get our answer to be 7.5. Here we have 11 plus 6 divided by 2, we get our answer to be 8.5. We have 9 plus 8 divided by 2, we get the value to be 8.5. We have 8 plus 11 divided by 2, we get the value to be 9.5. Lastly, we have 9 plus 11, we get the value to be 20, and the answer is 10. So this is how basically we create the sampling distribution data. We will attach another video which will explain more on how the sampling distribution data is basically used. Your host, Gordon Zulu.